Make sure you read the word not. Eventually, yeah. All right. So the answer to number one is what letter? Nope. Nope. It's C. Okay. Yeah, it's not. Think about what this is, by the way. That's almost table salt. Anything ionic is going to be a solid at room temperature. Okay? Now, this, people might think, well, that's an acid, and that is true, but it's not. This is hydrogen chloride gas, or it would have to say AQ for you to know it's an acid. And I know it doesn't say a gas, but if it, you have to just go with, it's a H and a Cl, that'd be hydrogen chloride gas. Hold on, stop talking. Hold on. I've definitely gone deaf the last 6 months of my life. Speak, child.
All right. So the question was talking about molecular weight, but does ionic make it?
It's a huge part of it.
Well, ionic makes them like stick to each other. So.
Right, they have the lattice structure and all that. So yes, it's kind of a trick question because it's like, well, hey, the Cl2 is the heaviest. All right. But by this time in AP chemistry, we should know it's a gas. All right. It's fluorine and chlorine. They're both gases. Bromine's a liquid. Iodine is a solid. Family 7 have those two that are gases. And then you'd think, all right, well, I know that's a gas. I don't know what this is. You know, like you might not. But definitely if something's ionic, there you go. All right. So I don't know. It's tricky, but that's the real answer. Okay. What is false about gases? You know, what's funny is being a homeschool father, my son Jace is on this same type of stuff and he's in 7th grade. I want to know what happens between 7th grade and your junior year, not you guys, but kids come to me and like they struggle with the states of matter. And I'm like, how? You're a freaking junior. I know you've learned this 10 times, but how do you not know solids have things close to each other and gases don't? Like, but they don't. Anyway, sorry. Pet peeve time. Oh, shut up. Okay. Can you compress a gas? Yes. Distance between gases are very large. Yep. Non-reactive gas mixtures are homogeneous. That's true. It means they mix equally. Like in this room, we have 77% nitrogen, 23% oxygen roughly. But it's not all the oxygen down there and then the top 3/4 is nitrogen. It's all homogeneous, means the same. Gases expand to fill the container they're placed in. Yes. So are all gases colorless? No. So E.
Wait, what gas?
Mustard gas.
Chlorine gas is yellow. Mustard gas yellow. Sulfur gas is actually reddish black.
Oh, what?
I know.
Sounds like something
It's
like
kind of
that.
weird.
That's like magician. Watch out.
When you look out at an inversion, like you drive towards Salt Lake and it's brown, some of that is sulfur dioxide. That's brown. Most of it's nitrogen dioxide, which is also brown. So gases definitely can be colored, and gases definitely stink. I mean, you should know. from being alive that gas smells. Yellowstone smells. Look at these sweet girls. They're like, yeah, Yellowstone. All the boys are like, yeah. Gas does smell better. All right, let's talk about our lab today.
And Tooele. Tooele smells bad.
Tooele does smell bad. That's
And I lived there. for
called
years.
lake stink. Okay, focus with me, like literally. Okay, in this lab, you'll be reacting magnesium and hydrochloric acid. You'll need to write that equation out. You have to balance it in order to do this. In this reaction, hydrogen gas will be produced. Is that the only product? No. So remember, there's some other thing. Your job is to use stoichiometry, yes, to predict the amount of gas produced, then perform the lab, compare the results, and determine the percent error. Yeah, it's everything. It's super easy. Don't stress. All right, so here's a couple of things. You have 10 milliliters of 3 molar HCl first. This stuff's in the fume hood. All right, you're going to fill the rest with tap water. I'll walk over there and show you what I mean in a minute. Then, really, don't even go past 1 centimeter of magnesium ribbon, and I'll show you what I mean there. And then you'll need this number today. This I looked up an hour ago. It's a beautiful, clear day, and you could have known that by looking at this number. That is high pressure. When we have high pressure, we usually have clear skies. And here's your nerdy weather event, because I can't not teach you weather. High pressure means that the atmosphere is pushing down a lot, which prevents moisture from going up. And moisture that goes up is what forms clouds. So high pressure prevents cloud formation. Low pressure encourages cloud formation. It's how you can predict. Go ahead, Fabian. Flirt with that girl. It's fine with me.
I didn't know.
I did.
I didn't do anything.
I know. I'm not mad at you. I said, go ahead.
No, I don't want to.
Oh, now she feels dumb. That worked out perfect for me. Yes.
You used the wrong band.
What?
You used the wrong band.
What did I even do it?
Oh yeah.
See, who
Dan,
goes up now?
Dan, instead of Dan.
Where?
No more then, or it should be
Oh.
Dan.
Whatever. Maybe
That's why the language teachers are mad at you.
maybe you guys could all eat crab. All right. So here we go. This thing is something we have not used before. It's called a eudiometer or eudometer, whichever way you want to call it. It is a just glass tube that's marked with graduations. Okay, here we go. Hi, Miller. It's okay. You're always welcome, but don't take any more ring stands. I forgot I was using them. We're good.
Oops, I think I'll figure out more. Oh, oops, I accidentally took the ring strand.
All right, that's the wrong one. Maybe that one.
That's why he didn't grab anything.
Should be some. Well, baking powder? Nope. Sorry. All right. Okay, everybody look at me right now. Everybody look at me. This one's broken. Don't move it. It will break your foot. It falls off. I'm going to put it right here. What group is going to take this spot? Okay, just don't lift it off the counter. Just leave it right here. Fair enough? It hurts. I know for a fact because I've dropped it on myself. Okay, here we go. The way this lab goes, you come back here. You need a what? Eudiometer. You need a ring stand. This one has a clamp. I don't even know if it'll be big enough. Yeah. Okay, then you'll have your eudiometer. You're going to put in 10 milliliters of 3 molar HCl that you get from the fume hood. That's the bottom. Then you're going to fill the rest with water. I want you to fill it carefully because I don't really want it to mix up until I want it to mix up. So you're going to tilt this and let the water gently roll down the side till it fills up. Easy enough? Someone do that in your lab group. The other ones, oh, it does fit. Now you're going to have it upside down eventually, but just for now it's holding that. Someone else needs to come over here and get a piece of string. There you go. I don't care how long it is, but it needs to be kind of long. And then just cut it. Okay? Then you're going to take magnesium and you're going to cut a piece off from this bigger piece. One second. All right. So no more than a centimeter, right? So it's not very long. You measure this out and you just cut that piece off. Now, I'm not being very accurate, but you will be. Okay, then your piece of string and your piece of magnesium. You try and roll it up. Now, it's a little bit brittle. So if it snaps, it's kind of okay, but you need all of it. So you've got it there. Then someone's going to tie, whoever's not doing this, you're going to thread this through and tie it. I made it too small. I mean, it's not that big a deal, but there you go. So you'll tie a knot so that your magnesium is tied on. You okay with that idea? Okay. My thread kind of came out on me, but it'll be good enough. Okay. So far, so good. Okay. Now, then you're going to work together a little bit. This is now full of water to the top. You take the magnesium and you're going to put it in the water, but it floats. It's kind of annoying. Use your pencil to sort of get it wet, and then it will go a little bit under. And so you have the string. The string needs to come out. And then you take a cork. The cork has a hole in it on purpose. And you're just going to put that in, and water will come out, but that's fine. So now you have HCl, water, magnesium, cork, thread. You're ready to go, almost, I guess, sorry. This should be full of water, not full, but at least halfway. You put it right here. And some of you will need to use the other type of clamps. Why did I get those? That's not at all what I wanted. Sorry. You'll have to pair up. I'll get more of these out in a minute. You'll have this on. So 2 lab groups will work right next to each other. Are you with me? Just put it in the middle. All right. So you will turn it over. Then that won't fit through now, but whatever. Yeah, it will. Turn it over. Make sure the end is underwater. And then you just let it happen. The hydrochloric acid is more dense. It's kind of cool to watch. You'll just see the light bend a little bit as it goes down. And then it gets to the magnesium, and then it's on. The reaction starts to happen. Hydrogen gas goes up, creates pressure that pushes water out the bottom. You do this until the magnesium is gone, like gone, gone. Don't ask me if it's over. The answer is if you can't see it, then it's over. Easy enough? Okay, when you are done, you need to lift it out and put your finger over the bottom. Okay, now pretend that was easier. And then you're going to come over here, and this will be full of water, like pretty high. It's a little trick. We need to make sure the pressure inside here is equal to the atmospheric pressure. And to do that, we put this with our finger on the bottom, we put it in water, and then move our hand away, and then bring the water level up to the gas level. And then it's pretty cool. That means the pressure out here and the pressure in there are the same. And they're almost the exact same anyway, but there is a little difference. So you go down there and you read your volume, and that's the number you need. This number's in milliliters, but your math you will do before is in liters. So make sure you realize you need to move the decimal. With me? Okay, now what math do we do to start with? Stoichiometry, which means we write out balance an equation, and then use the mass of magnesium to solve for the moles of H, which we use then in PIV NERT to solve for the volume of H. So we'll have calculated it math-wise, we'll have observed it science-wise, and we'll see if they match. Now, you need T, the temperature. There's thermometers back there that measure in Celsius. The rest is all right. Sort of with me? Okay, you got to wear safety glasses until you flip it over. If you don't want to wear them because it's frustrating, they'll fog up like super long. Get everything ready. You only need them for when we have the hydrogen being transferred and poured. Everything else, you can take them right back off. You okay with that? But at least have them on there. This will burn your eyes. It won't blind you, but it would really hurt. Okay, as always, try and fly through here when you get your mass of magnesium and get out of the way. So I only have a few ring stands. They're right here, and then Tolman's group's right there. So that's why you'll need to share some by using these. Okay, fire away. Done?
Yeah.
Okay. You plug all the iPads in?
What?
Will you plug all the iPads in?